Okay, so continuing our look at this phase portrait, we just had this region E left over, and because this graph was kind of crowded, I've just drawn a close-up of E over here. Now, E is completely enclosed by the nullclines. So the only way I could stay in E forever is if I'm approaching one of the equilibrium solutions. Technically, that means I'm not leaving E, but that'll be covered when I look at those equilibrium solutions. So I do need to look at if we could pass to an adjacent region. So that would be B or D. Notice A is over here and C is over here. Those don't really count as adjacent regions because the only point on the nullclines that's between them is the equilibrium solution. And I know I've got unique solutions in this case because the equations that described this system satisfy those hypotheses for the uniqueness theorem. So my solution curves can't cross. The only way I could go from E to A would be to cross through that equilibrium solution, and that's not allowed. Okay. So B and D are the two adjacent regions, and then both equilibrium points are on the boundary, so I want to see if I could approach those equilibrium solutions. Now, if I'm in E, I'm going left and I'm going up. Okay. So, could I start in E, go left and up, and go into B? Looks like I definitely could. Going left and up. I'm going to have a vertical tangent on this nullcline, and then when I pass into B, I'll start going to the right. Probably should have had these other arrows drawn in. These are right here. And let's see, these are down here. Okay. So I can go into B. Can I go into D? Now at this point, I'm going to swallow my pride and admit that I'm reshooting this video because I made a mistake the first time I shot the video. I said, well, look, if we're in E, we're going up, and D is below, so no, we can't. And then thought, oh, well, we can. Okay. So it's true that if I'm in E, I'm going up. But if I look at this boundary curve, it doesn't have up and down arrows. It has left and right arrows. So if I start in E somewhere around here, I can go up and left until I run into that nullcline. When I hit that nullcline, I can have a horizontal tangent and then start going down. Okay. So it is possible, even though I'm going up in this region, it's possible for me to go up to the nullcline and then pass into region D, which is below, because I can change direction there. Okay. So that was one that I feel foolish. I missed the first time a student pointed it out, and I said, oh, yeah, that's a mistake. That was me being very careless. So do make sure that you're looking. If these had been up arrows on the boundary, then I couldn't cross down. But if they're horizontal arrows and I can go up to the boundary, to that nullcline, and then change direction, I can cross into that region that's below it. So we can pass into D. Can I approach -1, 0? So can I get to here? Can I start somewhere in E, go up and to the left, and end there? Yes. Can I approach 1, 0? No. This is furthest to the right in E, and so there's no way I can go left and approach there. I can also see it would be possible for me to leave here. I could start at here and go away from that point within E. Now, it's not necessary to show that because I didn't ask you to trace your solutions back in time. Okay. But if I can go away from an equilibrium solution in a region, then I can't in that same region approach that equilibrium point. So sometimes that can be helpful in determining whether you can or you can't approach that point. Okay, so the answer was yes here and no here. So those are our possible behaviors for E. And so if I look at sort of the big picture here, I can see that it looks like both equilibrium points would be saddle points because I had some regions where I was approaching the equilibrium point and other regions where I was going away from it. So pretty powerful, these nullclines. They do allow us to classify these equilibrium points, And certainly if we did the linearization of the system, we could confirm that that educated guess that these are saddle points was correct. All right, so that wraps up our review videos. I just want to say it has been, for the most part, a pleasure being your teacher. And the times when it wasn't a pleasure weren't your fault at all. It was a rough semester switching to this online format. But you have been a truly phenomenal class. And I am really grateful to you, because sometimes knowing that I was working for you guys made it a lot easier for me to push through some of the tougher times, because you were such an amazing class. So thank you for rising to the occasion and making this new crazy sudden switch to online work as well as it did. Congratulations to those of you who are graduating from Saddleback and those of you who are transferring in the fall. Good luck to you in the rest of your academic career. I have really enjoyed being able to teach you, so thank you for that.